Part 2, we're going to use our identities to simplify some trig functions. So for the first one, pretty simple. Sine of x times the cosecant of x. Now my general rule of thumb is this, and I want you to write this down. Always use sine and cosine only if you can. If you can avoid the other functions, that's great. Switch everything in terms of sine and cosine. So if I take here, sine's already sine. But cosecant, I can rewrite that as 1 over the sine of x. So this is really saying sine x times 1 over the sine of x. And if you notice, these two cancel. And what are we left with? The number 1. So next time you're at a football game and you want to your team and say, hey, we are number sine x, cosecant of x. And of course that means we're number 1. Perfect. All right, so let's take a look at the next one. Sine of x over the cosine of x times the tangent of x. Simplify as much as you can. This is really saying the sine of x over cosine of x. We could rewrite tangent, remember, as sine over cosine. Sine x over cosine of x. And of course the bottom, the cosines cancel. And what are we left with? Sine of x over sine of x. And those cancel also to become 1. Cool. So far everything becomes 1. I like it. Next one, tangent cosecant times the cosine. Switch everything. How can we write tangent? Very good. We can write this as sine x over the cosine of x. Cosecant we can write as 1 over the sine of x. And cosine, we're just going to leave it over 1. And I just cancel. Look, the sines cancel. The cosines cancel. And what are we left with? 1 over 1, which was just 1. Now please, there's not a pattern here. Everything's not going to be 1. I promise you that. As a matter of fact, let's take a look at number 4 down here. A little bit different. Now, normally when we see a square, we always think Pythagorean. Now, if this were sine squared plus cosine squared, we could just say the whole top just equals 1. But however, we don't have that. That would be like too nice for us. So instead what we're going to do is we're going to remember an old algebra skill. Difference of squares. And a difference of squares, remember it says this. If I have a squared minus b squared, I could write that as a plus b, a minus b. And that's actually kind of what we have here. I could write this as the top as the sine of x plus the cosine of x times the sine of x minus cosine of x. And what's so nice about this, because if you notice the bottom, I have the sine of x plus the cosine of x. And if you notice, these two terms are the same. So I can cancel them out. And what are we left with? Just this sine of x minus cosine of x. And there's our final answer. Right. So let's see if we can do the same thing for number 5. If I try to factor, and I'll do it on top here just to show you something, I would get 1 plus the cosine of x times 1 minus the cosine of x. But here's the problem. Unlike in problem number 4, where when I factored it, the numerator and the denominator canceled, we don't have anything canceling here. So we have to think something differently in this situation because they don't cancel. So unfortunately, this is not a one-size-fits-all type of problem. So we actually have to kind of think about what can we use. So factoring won't work here. So I ask, what is 1 minus cosine squared? Do I have a rule for that? That's one of my Pythagoreans. Remember we knew this? If I had it's cosine squared of x plus the sine squared of x equals 1, I can use my Pythagorean. If I bring over the cosine, I'm going to get 1 minus the cosine squared. And that's going to be left with sine squared of x. So this 1 minus cosine squared is sine squared of x over the sine of x. And like anything else, if I have like x squared over x, we just get x. This square cancels with this one down here, and we're left with just the sine of x. This is a hard one. You may want to practice this one a couple of times. Heck, if you want to, try this one and bring it in class on Thursday or whenever we see you. Try 1 minus the sine squared of x over, let's try this one, cosine cubed of x. Try this one right here. Same idea. See if you can try that one. Bring it in and we'll see how we do. All right. Number 6. Now, anytime you have like a negative on the inside, they're talking about our even and odd relationships. Now, remember, sine is odd. Cosine is even. So what this means for us, if we have the sine of negative x, because sine is odd, this becomes negative sine of x. And that's what the top one becomes. Cosine is even, so that means that the cosine of negative x becomes just the cosine of x. And this is kind of a cool one because we have sine over cosine, which we know could be reduced to the tangent of x. And then we just bring that negative out. So we get negative tangent of x. And that's what this is equal to. Kind of fun to do. All right, let's take a look at a few more examples here. Make sure you get these copied down and try them. If you need to work them on another sheet of paper, don't be afraid to do so. All right, looking at number 7, simplifying. Remember, we don't want to use cosecant or cotangent, so I'm going to rewrite it. Cosecant becomes 1 over the sine of x minus, this becomes cosine of x, and I'm going to write this as sine x over cosine of x. Of course, these cancel. And I get 1 over the sine of x minus the sine of x. Now, we're pretty much almost done, but we do like to write these, though, as a single fraction. And so let me show you Wernow's way of writing a single fraction. Put a denominator underneath here. You get your common denominator by multiplying the two bottoms together. So I'm going to multiply sine times 1, and that's going to give me the sine of x. To get the numerators, I cross multiply. I get 1 minus, what's sine times sine? Sine squared of x. So if you got this far, you're actually doing pretty darn good. But we can go further, because this is one of my Pythagoreans. 1 minus sine squared, that's cosine squared of x over the sine of x. And if you get this far, that's acceptable for an answer. But we can even go further, and you should try to go further, because I could write this, since it's cosine squared, I can go cosine of x times the cosine of x over the sine of x. And I'm going to combine these two, because cosine over sine, we know, is the cotangent of x. And then I just bring down the cosine of x. And there's our final answer. That's kind of a fun one right there to do, and you will see one like this on your test and quiz. We do expect you to go all the way down to here. So practice this one. All right. Number 8, kind of like number 7, a little easier though. We are going to have to write a single fraction. So we're going to do a common denominator. So to do that, we are going to multiply them together. And if you recognize this, that's right, difference of squares, a plus b, a minus b. So this just becomes 1 minus sine squared of x. The numerator, cross multiply, I get 1 minus the sine of x plus 1 plus the sine of x. Sines cancel, we get 2 over 1 minus the sine squared of x. This is good so far. We're doing pretty good, but hopefully you recognize 1 minus sine squared of x is one of my Pythagoreans. This becomes 2 over cosine squared of x. Perfectly acceptable for this one, but we sometimes like to write this up on top here. So this becomes 2 secant squared of x. And there's our final answer. So what I would like you guys to do, before you come in, try number 9. Same way as number 7 and 8, you're going to need a common denominator. And I want to try number 10 with you real quickly. Now 10 is a very important one for us, because for number 10 they say we don't want to write this in fractional form. So we want to get rid of the fraction basically. So what we're going to do is rewrite it down here like so. Okay? And to write this in as a not fractional form, we are going to multiply top and bottom by the conjugate of the bottom. 1 minus sine of x. This is a very tough one right here to do. Now the top is pretty easy. We get 1 minus the sine of x. The denominator, the reason why we do it, use conjugates is to get a difference of squares. This becomes 1 minus sine squared of x. Now please, 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 this is me begging. Please, don't just cancel the 1 the sine squared of x. You can't do that. We wish then to be too easy. But instead, we should again recognize this one as our cosine squared. So we get 1 minus sine of x over cosine squared of x. And then what I can do here is I can split my fraction. I get 2 fractions here. I'm going to get 1 over cosine squared of x minus sine x over cosine squared of x. And there's numerous ways we can rewrite this one. Okay, simplest way, this is just secant squared of x minus. Now I could write this as a couple ways, but an easy way, just keep this as sine of x and bring up the cosine that gives us secant squared of x. And there's our final answer. I could have also done this if you wanted to. This is secant squared of x minus, and this one, remember, I can write this as sine of x over cosine x times cosine of x. There's tangent, so I can write that as tangent of x and bring the cosine up times secant of x. Either way is acceptable. The nice thing about a lot of these, there's many different answers you can get. You just want to do the best you can. Alright, so for notes class tomorrow, I would like you to try number 11, and we'll go over that as a class. Thank you guys, and I'll see you guys tomorrow.